everybody, and welcome to myself Learn Extra. My name is Trini, and today we're having this awesome teacher in studio with us. It is Michelle. Hello, Michelle. How are you?
Hello, Trini. I'm fine, thanks. And you? Thank you so much for having me.
Great stuff. So, Michelle, which school are you representing?
I'm representing Fourways High School in Fourways.
Oh, great stuff. Wow. It's also good to be with you today.
Thank you. I'm very nervous, but I'm very excited to say
yeah. Great stuff. Well, thank God. For those of you who just tuned in right now, welcome to the show. And yes, we also do have another master in studio with us who is going to be joining us, tackle some questions that Michelle will be asking him. And yeah, so hello, Michelle, how are you doing? Thank you. Oh, great stuff. Just know that please remember to stop on our page so that you can participate on the show with us right now, right there on mindset.co.za/learn/extra/winter school. It's just as simple as that. And one of the great things that I have for you guys is that we are having this awesome competition coming from Soul Candy. We will be giving away these awesome pieces over the day. It's a lot of things, and we gave people since the month of yesterday, and we gave away one earlier on the last day that we had. So all what you have to do is just to enter this competition on our website. It is mindset.co.za/learn/stop-the-track. So basically what happens is you choose any number between 0 and 9. Choose that number, and it is going to be taken from the number of lives that we have. We will be taking the last digit on the number of lives that we have. All of the information will be posted on our Facebook page. So all we have to do just to go straight there and read through and see what we all have. Right now, without any further waste of time, let me just give Michelle a chance to teach us a little bit more about geography.
Thank you so much, Trini. Alright, today we're going to go through some of the questions from the Geomorphology and the Climatology section from the February 2012 NPS paper. We have a look down. Let's move straight on to our first question. Okay. Question 1 says, refer to figure 1, which shows fluvial features, and give one term for each of the statements below. Let's have a look at the diagram. What is always extremely important to do before attempting to answer any of the questions is to make sure a person reads the instruction properly, and also to have a look at each of the definitions on the given diagram so that you can identify them for yourself before answering. If we have a look at each of these definitions, let's go through them slowly to make sure that we understand. So have a look at the first one here, a confluence. If you have a look at where confluence is pointing to, you will see that it's pointing to where two small streams or small tributaries are meeting. So in other words, a confluence marks the two streams which join at a particular point. If we have a look at the word surface flow, surface tells us that the water is flowing above the ground surface, so on the surface of the earth. If we have a look at interfluence, you might have recognized similar terms such as spurs and bluffs in the grade 9 syllabus. So the interfluve in this context means that it's a high-lying area which separates individual tributaries. If we have a look at watersheds, watersheds can also be used with the term drainage device, and it means the high-lying area which separates one drainage basin from the next. If we have a look at the term river mouth, you will see that it's pointing to literally where the river ends. So where our river ends and enters into the sea, that is known as the river mouth. Now that we've had a look at our diagram, let's see if we can answer the question. You'll note that each of these short questions is worth 2 marks each, but your one term or your one word will constitute those 2 marks. 1.1, water that flows on the surface after it rains. So it flows on the surface after it rains. Surface is our key word here. So if we have a look, surface flow. And you will see that that was on the diagram. Most of the time you have to look at your diagram and they give you key pointers there. 1.2, a high-lying area that separates two different drainage basins. Okay, it separates two different drainage basins. As I said before, watershed, or they will also accept the same drainage divide. 1.3, water that is found below the surface of the earth. Okay. As was pointed out in your diagram, groundwater. 1.4, the point where the river enters the sea, as indicated on your diagram, river mouth. And lastly, for this particular little question, it shows the division between the tributaries, individual tributaries, in the same drainage basin, as was on your diagram, the term interflow. Any questions so far, Sivisu? Awesome. I just want to reinforce a couple of those terms. You will notice that the same diagrams will not come up time and time again in each exam that you've written. So what will help you is to actually do a simple Google image search and to look at various features like drainage basins or mesas and buttes when you get to that, and you'll find that there are literally millions of versions of those diagrams. So the more you look at those diagrams, the easier it becomes to identify those features. So let's see if we've learned anything now. A, if you have a look at where the dotted line is pointing to, you see the high-lying area that's separating our drainage basin. What does that call? Can you remember? Yes. No? Okay. You just need to remember it's called a drainage divide or a watershed. Okay, let's go through some of those as well. If you have a look at point B, you will see that it occurs in between two tributaries. So it's a high-lying area between two tributaries. Do you remember that?
Interfluve.
Interfluve, very good, very good. We have a look at C. They will probably just accept that it's a tributary. It's not pointing to a confluent, so it's a simple tributary. If we have a look at E, you will see it's pointing to where we have two streams meeting, so that would be a confluence, as you said earlier.
Okay.
And if we have a look at D, you can see it's the end of our river system as it enters the sea. And what's that called?
The river mouth.
Very good, the river mouth. Let's move on to the next question. Right, question 2. Always important to read the instruction carefully first. It says refer to question 2, or figure 2 rather, showing a river basin. If we have a look at that diagram, you will see that there's quite a few things going on here. You'll see there's a fairly complicated stream network at B. You will see that there's a dotted line to represent a river at A. You will see the river Ron at C, and you will see that there are settlements at D, and there's also a forested area not too far away. If we have a look at each of the questions, it says to identify the type of river labeled A. So if we have a look here, a dotted line when you're looking at your map, okay, usually represents a river that doesn't flow all year round.
Can I try?
Yes, of course.
Non-perennial.
Non-perennial, very good. It means it doesn't flow throughout the year.
Yeah.
There are other options though. Let's have a look at them. Okay, so the type of river at A could be non-perennial, or they will accept periodic, or they will accept seasonal.
Yeah.
Then it says to determine the stream order at B. Let's have a look at B. You will see at B you've got quite a few streams, and we need to determine that stream order. So the best way is to start from the outside, okay, from the earliest points of your river streams, and work your way in. So if we have a look, if we just use a couple of colors here, you will see that we've got a stream starting all the way at the top by Cap Mountain. Okay. I'm going to stop where it joins another stream. If you have a look, another little stream, and you'll see that they are joining together. Those two little pink streams that I've just drawn in are called first order streams. So your first tributaries, the first streams which flow from your watershed towards the confluence, is called a first order stream. When we have two first order streams joining, it now becomes a second order stream. It follows on that if two second order streams join, they become a third order stream. Now I've got a diagram here to show you what I mean a little more clearly. If you have a look at the color representations here, you will see that two first order streams have to join together to make a second order stream, and two second order streams have to join together to make a third order stream. All right, so Sfisu, if you have a look at that diagram, or the one that you've got on your page, can you figure out, or have you figured out what the stream order should be?
Should be stream order. The third, 3.
Very good, it's a third order stream. So it's very important that you actually take in some color pens, or take in different colors, and actually draw on your paper so that you can figure out what the different stream orders are. Move on to the next question. It says here, explain how the forested area will affect the stream discharge. And they've told you what stream discharge means. It literally means the runoff. Okay. So we've got to think about, if we have a plantation that's planted right next to a river network, what is that going to do to our water supply in that river network? Okay. So, Sfisu, what do you know about forests? What do they literally do to the water?
They absorb the water.
They absorb the water, they absorb the runoff. So there is a first clue, all right? So if they're taking that discharge, if they're absorbing that discharge, it means that it's going to reduce the flow. It's going to reduce the discharge, okay? It literally takes up, it intercepts the precipitation. It adds to the rate of evapotranspiration. That's an important term. Evapotranspiration means the loss of water through the pores of the tissues of leaves on plants. Okay? So it means it increases that rate of evapotranspiration. The roots of the plants will take up water, so roots are important, and they will reduce the through flow. So they will reduce the amount of water available to our groundwater. We have a look at the next question. It asks you to identify the drainage pattern, okay, so just to identify, not explain, evident in the area called the Cap Mountains. So we're going to have to look at our diagram very quickly again. If you have a look at that diagram, you'll notice that the stream or individual tributaries represent branches of a tree, okay, or they look like the roots of a tree. So when they resemble that pattern, we call that a dendritic pattern. All right, so our answer for that one should have obviously been dendritic. 2.5, river capture has occurred at point C. River capture comes up in literally every single exam paper, so you really do have to know this concept quite well. Now, if we have a look, it says A, explain the concept of river capture. So explain river capture means you actually have to write a proper sentence detailing what happens when one river captures another. Sfisu, this is a tough one, but can you remember anything about river capture?
I think I forgot, eh?
Yeah, as most of my students have as well, I'm sure. All right, when it asks you to explain, it's very important that these key concepts become part of your general knowledge, all right? Because they will always ask you for a concept, and then they will ask you to lead on or answer further questions based on that concept. So your core definitions, your key definitions are very important. Okay, so our definition for river capture, it means one river, usually a river which has more energy, it captures or it robs or steals, you can use the word steals as well, the headwaters of another river, and so increases the size of its drainage basin. Let me repeat that once more. It's where one river captures or steals the headwaters of another river and so increases the size of its own drainage basin. They will not accept a definition if it is half, okay? So you can't just say one river captures or steals water from another river. You have to say it captures the headwaters of another river and increases its drainage basin size. We have a look at the next question. This is the follow-on question from your key definition. It says to suggest two characteristics that River Ron would have in order, so we're looking at River Ron, to have captured another river. So that suggests that River Ron has done the capturing. All right. So I've mentioned in the definition before that river capture occurs when we have a more energetic stream capturing the headwaters of a less energetic stream. Okay? So that means River Ron has to be the more energetic river. So Sfisu, from a logical point of view, what causes a river to have more energy?
Could be the mountain, the form of
What
probably
about the mountain?
if it's steep or it's gentle, could be influence its speed of the flow of river.
Excellent. So when we have a steep gradient, it means the river's going to flow faster
yeah.
and it's going to erode more. Very good. Okay. There are other options as well. We have a steep gradient, as you correctly said. If we have more rainfall, so greater rainfall, okay, steep gradient, softer rock, which means it will erode more easily, and a lower flow level, which means that the river that's doing the capturing, the capture river, means that it's flowing at a slightly lower level than the river that is capturing the headwaters of. We have a look. What impact does river capture have? Okay, so the impact that it's going to have on settlement D that occurs along the Misfit River. Let's have a look at our diagram. Settlement D. River Ron, if we have a look, will have captured that water. Now settlement D, okay, is located close to the Misfit River. All right, and our Misfit River, there it is there. So a misfit river means that it doesn't fit into the drainage basin system anymore. And you will see here, right by letter C, that it's been cut off from the rest of the river. And when it gets cut off from the rest of the river, it means that the water levels that it holds are now reduced. In other words, it has less runoff. It has less surface flow. All right? So if we have a river with less surface flow at settlement D, how do you think that's going to impact the people that live at settlement D, Svisa? If you've got less water flowing in that river, how would it impact you if you were living in that area?
We wouldn't have water to live, I think, for drinking.
Good. So we wouldn't have water for domestic use.
Domestic use, yes.
Our
Basic
normal
needs.
everyday needs. Good.
Yeah.
In addition to our domestic use, what other things, Safisu, do we have to have water for?
For planting crops.
For planting of crops, for agriculture, very good, for our livestock. Okay.
Yeah.
Let's have a look at the answer. It asked you just for 2 points, 2 times 2. Okay, so it means you have to explain each of them. There's quite a few options that you're going to find here. Okay. Once that decides to work. Right, less water available for agriculture, very good. Less deposition, therefore a drop in soil fertility. A decrease in production, that could be anything involved in agriculture and livestock. Economic decline, because we now have less product to sell. Lower volumes in water will be available for domestic as well as industrial use, because everything that we make in a factory also involves water. Our aquatic, our water organisms will perish because the water is reduced now, so they'll die. Food chains, therefore, will be disrupted. and ecosystems are thrown into a state of imbalance. You need to remember that individual organisms in food chains, they rely on each other. And if you remove one organism from that food chain, it means the whole food chain is disrupted, and therefore the ecosystem is disrupted. Thank you, Pumi. I think it's time for a break.
Definitely. Wow, guys, it is now time we take a quick break, but let me remind you something, that please post all of the answers to the question that we have for you, or rather the competition that we are running for you guys. That don't post it on the wall, but jump onto our page. It is mindset.co.za/learn/stop the clock. There is a form there that you have to fill in, and then you can make a guess of any number between 0 and 9. And when we come back from an ad break, we are going to be continuing with more learning and extra. Let's do this. Welcome back from the break, Mindsetters. We are still doing winter school revision with the exams and everything like that. And today we do have Michelle who is taking us through geography. But before that, guys, let me quickly remind you about the competition that we're having. We are giving away this Musat DVD, proudly sponsored by Soul Candy. So all what you have to do is just to fill out a form that we have for you on our website. It is www.learn/stop the clock. So you can choose a number, any number between 0 and 9. More information is posted on our Facebook page. Right now, let's do this, Michelle, and get learning.
Thank you very much, Pumi. Welcome back. Let's do some more geomorphology. All right, let's have a look at question 3. We're still looking at river and drainage systems. It is a really difficult section, but if you know your key terminology and your key processes, you'll be able to answer any question based on any diagram that they might throw at you in the exam. Let's have a look at our diagram. You will see that it tells you what type of profile it is. It's a cross profile. Other words that they might use besides cross profile are transverse profile. It's important that you know each of the terms that are linked together, like cross and transverse, because they could use either. So you need to know what you're looking at and what they're referring to. Right, you will see that it's not a particularly clear diagram, and we'll see what each of the labels are telling us here. It's not too clear, but we're going to work it out. All right, it tells us that firstly, it's raining really heavily. Okay, so it's a downpour. It tells us that the rain can't soak into the ground fast enough, so it's running over the surface. In other words, it's got more runoff or more surface flow. It tells us that the infiltration is slow. It tells us that the through flow is slow and that the groundwater flow is slow. So it tells us that there's not much water penetrating the ground. If we have a look at what's going on above the surface of the earth, we've got surface runoff that's very fast, okay? And it goes into the river, and the river level rises very rapidly and the river floods. So our runoff levels are extremely high. You will see also that they've given you the cross profile or the transverse profile at A of your river. You can actually see what the shape of the riverbed is showing you. Let's go to our questions. It asks you to identify the river profile labeled A. Okay, so river profile labeled A. If you have a look at the diagram, it's actually giving you 3 marks. It tells you cross profile. Okay, so look at your diagram, they give you good hints. So our answer therefore should be a cross profile. 3.2, then it says, give 2 possible reasons for the rainwater not soaking into the ground. Okay, so we need 2 reasons. The rainwater is not infiltrating into the ground. Okay, so if it's not infiltrating, it means that the surface runoff is occurring very, very quickly. If you look at your diagram again, you will see that they've given you a few hints. If you have a look, it tells us it's raining very heavily. And when it rains really, really heavily, there's so much water that it doesn't get time to infiltrate into the ground. If you have a look, it tells us that the rain can't soak into the ground fast enough. So perhaps the ground levels are already full. They're already saturated with water. It tells us that our groundwater flow and our through flow is all slow. which might also suggest that the type of rock or soil that it's flowing through is of a nature that doesn't allow water to flow through. Sifiso, do you remember the word that they use for a type of rock that doesn't allow water to penetrate?
I forgot, eh?
You forgot? That's fine. That's what we're here for.
Okay, yeah.
They refer to it as non-permeable or non-porous rock.
Okay.
We have a look at what they tell us. In the diagram, it already gave you a couple of answers. They're only looking for two things. So heavy rain, means it's going to flow along the surface of the earth rather than seep into the ground. A steep slope, that means that the gradient is too steep in order for infiltration to occur. So it's steep, the rain's heavy. The ground is almost saturated, which means it can't hold any more water. Rock with a low porosity. Now I just want to define porosity for you. A pore is an individual airspace that occurs in this context between soil particles. So the more pores you have, the more the water can flow through. So low porosity means that the water has not been allowed to go through. A low degree of permeability. So low permeability. Permeability means that there are no gaps or cracks in the rock that allow water to seep through. So if it's a low permeability, it means there's no infiltration. It means there's more surface flow. A lack of vegetation. That's a common one as well. You will have learned, hopefully, in grade 11 syllabi, that vegetation helps to hold the water back. So the more vegetation that you have, the more the roots will absorb, the more the water will be held back, and so more infiltration. If you remove that vegetation, it means that the water is allowed to just flow along the surface. Let's look at the next question. 3.3. Flooding of rivers is largely due, so it's due to river mismanagement. So mismanagement in opposition to management means that you're not managing it. So you're handling things badly in your river system. You need to write a paragraph, and stick to the instruction. Write a paragraph. Don't put it in point form. Approximately 12 lines or 10 to 15 lines, as is written in some papers, suggesting ways in which humankind mismanages river environments. So you need to think about things that people do that harm river environments, that perhaps pollute river environments. So, Sfisu, I'm not going to put you too much on the spot here. Can you tell me one thing that we do that perhaps would pollute or destroy a river and its environment?
The river and its environment could be in the industries, the discharges that they have in the industries, the oils and whatnot.
Excellent. Yes, that's perfect.
So
industrial waste, we have a term
industrial
for that.
use, yes.
It's called effluent. Industrial waste called effluent will sometimes get into the river system and they will pollute it. You can also talk about pollution in terms of domestic use. Domestic pollution or litter that we throw in the rivers is also a good example. What about waste such as sewage? That gets into the rivers as well. Now, besides pollution, what other factors do you, as well as you, Sfisu, think could kind of tamper with the river flow? What do we use a river for that will take away its flow?
For aquatic life, we take.
What do we do to the aquatic life?
It's for fishing, for fishing, I think.
So in a way, you're right. You're saying that the fish get disturbed either by the pollution.
Yes.
All right. If we take too much of their habitat, like their water supply or their environment, or destroy their habitat, we could also influence their lives that way, besides taking fish out of the water. So if we have a look, there's a couple of them there already. All right. So we discharge sewage and industrial waste, as you correctly mentioned. The act of deforestation is also pertinent in terms of river flow disruption. Over irrigation. Over irrigation means that we're using too much of the water in terms of our cultivated land and our agriculture. So if we're taking away that water supply, it means there's nothing left for the aquatic life. There's nothing left for the species that inhabit those areas. If we have more settlements, okay, we're going to also influence our flow of our river because we're using that water for our industry. We're using it for our domestic use. If we over-cultivate, we're also going to disrupt river basins. We're going to take away natural vegetation. We're going to plant alien vegetation there. Okay? Overgrazing. Overcultivation, overgrazing also lead to things like soil erosion. And more soil or sediment in our river also influences rivers and how we mismanage them. We have a look at a couple of the other options there. Our chemicals that we use in agriculture, wasted, they get transported into river systems by surface runoff. Now there's a specific term that I've drummed into my students this year and last year, which we use for all of those chemical fertilizers going into river systems, and that's called eutrophication. Okay? Eutrophication means all the excess chemicals, they're polluting the water. It's changing all the chemical balances in the water. It's changing the species of plant that live there. It allows invasive species to grow there instead. The construction of dams is also a big one. Okay, we've got many dams in our own country in terms of water transfer schemes, and when we construct a dam in one area, we disrupt the flow in another area of that same drainage basin. It literally decreases the volume of water further downstream. Okay? We mentioned our fish populations and our aquatic species that might get affected. Okay, so our river ecosystems are also thrown into imbalance. So all the fish, all the aquatic species of plants and animals that live there, that delicate balance becomes disrupted. Any questions so far, Safisu?
No, so far I'm good.
That's good. That's good. I'm glad to hear that. All right, let's move on to our next question. Okay, if we have a look at the figure, it asks us, or it shows us various fluvial features. Okay, so fluvial features are what we're looking at. It says to choose, okay, from a variety of options, the correct word or words or terms or phrases from those that are given in brackets. Okay, read your instruction carefully. Often they're giving you the opportunity and they're giving you selections of words. So even if you're not too sure, there's always a chance that you're going to get something right. Okay, so if we have a look at our diagram, you'll see that we've got various features that are indicated. Let's have a look at each of them first. You will see that they've shown us an X to Y or cross profile, okay, which we're going to have a look at a little bit later. You will notice at E, we've got a little lake forming here. Okay, that's called an oxbow lake. You will see at G that our river forms a meandering pattern. Okay, so we're looking at a river pattern, we're looking at the features associated with that pattern as well as the processes. Okay, so from the options that are given to us, it says, name the slope that forms on the river labeled X. Now there's a trick to getting to know this. If you have a look at the arrows that are indicating your motion of water, you will see that our arrows are hitting the outer bend quite directly. So our water is flowing directly into that outer bend. Okay? So the outer bend has the full force of your water. Okay? And when you have lots of water rubbing and crashing into the side of that river continuously, it starts to erode it. So at X, we're going to have what we call a river cliff forming. It's going to erode literally a cliff into the river. Okay? Let's see if they give that option to us there. Okay? They tell us that we can choose from undercut slope or scarp slope. Now you need to make sure you don't confuse terminology between different sections within geomorphology. Okay? So we've got either undercut slope or we've got a scarp slope. Now, if you know your definitions well, you should already know that scarp slope pertains only to your inclined and horizontally layered rock strata formations. So that should immediately cancel it out. I said a river cliff, okay, can also be called an undercut slope. the erosion has literally caused that river to cave in on one side, undercut. Okay, so undercut would indeed be our correct option there.
Sorry, Michelle.
Yes.
You said the scarp slope only occurs on the horizontal.
Yes. When we're looking at things like mesas, when you're looking at things like buttes, okay, as well as your inclined rock strata, when we get later on looking at homoclinal ridges, that terminology goes with that section. Okay. So undercut slope is indeed our correct answer here. Let me just circle it. Right. If we have a look at the next little question. The name of the slope labeled Y, they give you the options, dip slope or a slip-off slope. Again, if you know your terminology really well, a dip slope can only be associated with your inclined rock strata, like homoclinal ridges and hogsbacks. Okay? So that should immediately cancel it out. Okay? If we have a look, we've got a slip-off slope, which is our other option. Okay? Slip-off slope would have to be the correct answer. All right? If we have a look at the diagram, you will see that there are lots of little points or dots indicating that there's deposition occurring at the Y side of your cross profile. So when we have lots of deposition, it means that the river flow is slower. Okay, it has less energy, so it's depositing more. Okay, so it's going to deposit all that material at Y, and we call that a slip-off slope. You need to know your terminology very, very well, please. All right, let's move on. 4.3, feature E that forms when a meander loop is cut off. Okay, so it's cut off from the rest. It can either be an oxbow lake or it can be a meander neck. Let's have a look. You will see that feature E, forming a little lake, it's been separated. It's been removed from the rest of the meander. It's no longer a part of it. We call that an oxbow lake. Again, simple definitions that you need to remember. Even if you recite them until you're blue in the face, you need to remember those definitions off the back of your hand if you want to get a distinction for the subject. Right, so our only option there, or the correct option rather, an oxbow lake. 4.4. Deposits F that occur on the banks of a river. You can choose silt or you can choose scree. Again, scree is associated with our horizontal rock strata, so you need to know which elements fit with which sections in your syllabus. The correct answer, of course, is silt, weathered material that gets deposited on and around a river bank. Okay, 4.5, let's have a look. The area adjacent to the river that flows or floods when a river overflows its banks. Okay, so flood is your key word here, should tell you something. Okay, obviously it's going to be a flood plain. Okay, the levees are actually features that can be natural or man-made, which raise the banks or increase the size or height of the banks of your river so that your river doesn't overflow. So your floodplain is when the river overflows and obviously accumulates lots of rich deposits of alluvium. It's actually very good for farming. This is why people live in and around rivers, because of that rich alluvium that's deposited. Pumi, I think it's time for a break.
Alright then guys, let's take a quick break, and when we come back we are going to be learning more and learning extra. And we are back again on the show. Guys, remember that we are running this exciting competition and we are giving away this awesome CD. So what you have to do is just to jump on our page and enter this competition by filling in this little form and guess a number from 0 to 9. And speaking of which, Michelle, can you please jump onto the page and see how many likes we have? Oh, great stuff. We are sitting at 45,071. Right over there, if you check the last digit of the number of likes on Facebook, it's 1. So all of the number ones at home, probably you're gonna win, but hey, we can't really promise you that for now because people are liking. So please get your friends to like and like and like. It can soon enough change to 8, it can change to 9. So get your friends to like so that it can stand at the number that you decided to choose. And right before, right at the end when the clock has gone off or rather stopped, you are actually going to be announcing the winner. And again, guys, this is one of the exciting things that you are going to be winning at home. It is a nice city bag with nice bags inside where you can put in your CDs inside. Right now, guys, I'm sure that you heard about this new show that we have right here on Mindset. It is called Connections. The Facebook name is Mindset Connections. Please like them because tomorrow they are going to be talking about a body image. It's a very nice and exciting show. Please interact with them and get your friends to please like them, and let's interact and everything like that.
Thank you, Mpumi. Now we're going to move on to my favorite section of all time called Climatology. Now, in case you thought the weather is boring and learning about climate is boring, it's not. Mpumi, are you ready? Tabitha, are you ready?
I'm ready.
Good. All right, let's have a look at these past questions. Question 1, it tells you that figure 1 illustrates air pressure belts over Africa, and that we have to answer the questions by matching each question with a term from the list below. Now, when you're writing your exam, you're stressed, there's not enough time to finish the questions, so you tend to speed read and you tend to skip over valuable information, and I've seen this in my past papers that I've just been marking as well. When you're reading a question, make sure you follow the instruction. Make sure that you see, in this case, that there are a list of terms, okay? Don't try and make anything up by yourself, okay? Otherwise you're going to lose the marks. All right, so if we have a look at this diagram, you will see it shows us Africa, it shows us 3 lines of latitude, 30 degrees south, the equator, 30 degrees north, and it shows us the air motion. It shows us where the air is rising, okay, over the equator. All right. And it also shows us where the air is sinking. And the sinking is occurring towards 30 degrees south as well as 30 degrees north. Okay. When they ask you any questions with regard to pressure belts or the tricellular model or global air circulation, if you can remember 3 simple categories of information, you can adapt it to any diagram that you want to look at. All right. So they mentioned pressure belts. Okay. Now we have 4 different pressure belts. They also mention where we have various cells in the question. So we have 3 different cells, as well as wind belts. Okay, now there are 3 sets of wind belts. If we have a look at the ones, or the pressure belts, the wind belts, as well as the cells that pertain to this diagram, you will see that our air rises over the equator. It rises at the ITCZ. Svisu, can you remember what ITCZ stands for?
Yes.
What is it?
It's the Intertropical Convergence Zone.
Excellent. Intertropical Convergence Zone. And the ITCZ at the equator is associated with very, very hot, humid conditions. Okay? They get a lot of direct, intense heating, so air will rise at quite a rate off the Earth's surface. So when air rises, Sifiso, what type of pressure is formed when air rises?
It's the low pressure.
Okay, it's a low pressure, but at the ITCZ, what is the name of that pressure belt?
Subtropical belt.
It's a tropical belt, a tropical low pressure.
Okay, yeah.
The most correct word that you can use for that is the equatorial low pressures. Okay, you'll notice that if you can identify whether or not it's a low or high pressure, okay, then you're fine. And usually they're named where they're coming from. So the equator, equatorial low pressures. So equatorial low pressures at our ITCZ. At 30 degrees north and south, my blue arrows indicate that the air is sinking. So Sfiso, what type of pressure is created when we have sinking air?
I can't remember properly.
Okay, let me refresh your memory. We've got low pressure and air rises. is
Oh.
sinking.
Sinking, it's high pressure.
Very good. It's a
Yeah.
high pressure. All right. So at 30 degrees north and south, we have a high pressure. Now, 30 degrees north and south are called the subtropics. Our pressure belts are named from where they're coming.
Yes.
So the subtropical high pressures are what we're dealing with. So in our group of pressure belts, on this diagram, we're looking at the equatorial lows at the equator, and we're looking at the subtropical high pressures. All right. We've also got one wind belt that we're looking at. Okay? Remember, winds are also named in terms of the direction from where they're coming. Right. So if we have a look at my pink arrows here, right, they're coming from the east. Okay? So that means that they're called easterlies. Okay? They're in the tropics, so we're going to call them tropical easterlies. All right. You'll notice as well that our arrows don't just flow straight up or down, or in this case it should be towards the equator. Okay? What force, Fisu, can you remember, causes them to be a bit deflected?
It's the deflecting force called the Coriolis force.
Excellent, Coriolis force. Okay? Now they often ask an additional question with Coriolis force. Okay? They'll ask you to name and describe the law of Coriolis force. And the law is called Ferrel's law. Okay? And it says that if you're standing with your back to the wind, it tells us that the deflection is to the left in the southern hemisphere and the right in the northern hemisphere. And that's called Ferrel's law. If you have a look here, our circular motion of air, indicated by the pink and the blue arrows, tells us that we're also dealing with a circulation cell. So the cell that's closest to the equator is called our tropical cell. Or is there another name for it? Can you remember, Sabisa?
The name for, sorry?
The cell between 0 and 30 degrees north and south.
Mm.
One word is a tropical cell. Is there another one you can remember?
I think I forgot the name
That's
as
all
well.
right. That's what we are. It's called the Hadley cell.
Oh.
Okay. So in terms of our three categories of information, we've got two pressure belts that we're looking at. We've got one wind belt, the tropical easterlies, and we've got one cell that we're looking at. Okay. So if we have a look at our questions very quickly, you'll see that some of those options are coming up. All right. So for every single question, we have to choose from the list given to us. All right. 1.1 says, name the pressure belt South Africa is located in. So if we have a look at our map, okay, we know where South Africa is, I hope by now, and roughly over 30 degrees south is where we're lying. So the pressure belt, as I revised with you now, over 30 degrees south is called the subtropical high pressure. Let's see if that option is presented to us. Okay, subtropical belt or subtropical high pressure belt. That would be the correct answer there. All right, 1.2. It asks us, what is the name of the belt where the tropical easterlies converge? So your word converge is extremely important here. Okay, we just revised what the ITCZ was, the Intertropical Convergence Zone, and I asked Sifiso what that belt was called at the ITCZ. We discovered it was called the Equatorial Low Pressures. Let's see if they've got that option there. They've got the ITCZ, so ITCZ will be the correct option for 1.2. 1.3, what is the name of the force that deflects winds to the left in the southern hemisphere? Okay? So I've just revised Ferrel's law that tells us that winds get deflected to the left in the southern hemisphere and the right in the northern hemisphere. But what was that force called? Let's see if Sfisa's been listening. What is it called?
Coriolis force.
Excellent, Coriolis force. Let's see if they have the option. All right. There you go, Coriolis force. An additional question that they might ask with regard to Coriolis force is where its presence or its force is greatest, at the equator or at the poles. Now you must remember, especially when you're dealing with tropical cyclones later on, that Coriolis force is 0 at the equator and it is strongest at the poles. They often put that question in there. So just remember, Coriolis force increases in strength as you move closer towards the poles. Let's have a look at our next question. name the winds. So we're looking at our wind belt that diverge, so in other words, move apart from the 30 degrees north and south latitude. Okay? So we know that our tropical easterlies converge at the equator, so it can't be our easterlies. Okay? If we have a look at 30 degrees south, okay, we know that air will diverge from there. Okay? Okay, oh, wrong way around. My apologies. Let's just fix that. Okay, so it's diverging. Okay, we have winds that are coming from the east here. Okay, and we have winds that are moving towards the polar regions. Let's just fix this here. Okay, right, towards the polar regions. Note the direction that they're coming from. Okay, so I'm looking at this wind here. It's coming from 30 degrees south and it's coming from the west. So wind belts are always named from where they're coming and going, so they must be called the westerlies. Now there's only one group of westerlies, so we don't have to add another word to the beginning of that. So westerlies should be fine. We have a look. Let's see if the option is there once more. Oh, go down. There we go. Westerlies is there. So our correct option for that question would have been westerlies. Right, next question. 1.5. Identify the name of the cell associated with warm rising air at the equator. I said to you this particular diagram was dealing with one particular type of cell. It was called the tropical cell. Let's see if Safisa remembers now what the other word for tropical cell is.
Hadley cell.
Hadley cell, excellent. Let's see if they give that option. Okay, the Hadley cell's right there, so that's the correct answer. Very, very good. Let's move on to the next question. Okay. All right. If we have a look here, the instruction tells us to, or it shows us a cross section. Okay, so we're looking at a cross section or a transverse section through a line thunderstorm, which develops along a moisture front or a trough line. Okay, trough is another word that can be used for low pressure. A moisture front means that two air masses of different moisture content are meeting. Okay, cross section means that we're literally cutting it in half. Okay, we often get these storms, and especially in our early summer months, roughly October, maybe even November. Sometimes in the middle of the night you'll wake up and there's a whole string of torrential downpours, lots of thunderstorms, lots of hail and lightning. Those are traditionally caused by line thunderstorm developments. Okay, so if we have a look here, let's analyze the diagram. At point B, you'll see there's a lot of red arrows which are moving up. Okay, that insinuates that our air is rising. The red insinuates that it is warm. So our warm air is rising. If we have a look at our blue arrows, okay, the air is sinking. And air that sinks is generally cold. It's generally very dense, very heavy air. Okay. If we have a look at the black line, okay, that is showing us where those two air masses are meeting. So that black and yellow line is our moisture front. Okay. All right. Now I have a map to show you how this works on a synoptic level, but let's just go through the questions first. All right. So our warm rising air comes from which ocean do you think in South Africa or around the coast of South Africa? Sfisa?
Warm.
Warm, yeah.
From the Indian Ocean.
Good. Our Indian Ocean is warm.
Yes.
Which is our slightly cooler ocean?
Cooler ocean, the Atlantic Ocean.
Excellent, the Atlantic, okay. So if we've got warm air coming off the Indian Ocean, okay, it's going to rise, okay. We've got colder air coming off the Atlantic Ocean, it's going to sink, it's going to be more dense, okay. We have a look at the questions. It asks us to 2.1 explain the meaning of the term a moisture front. Okay? As we've just seen from our diagram, we saw two different air masses meeting at a black line, at that moisture front. Okay? So it's a zone where two differing air masses, usually with different moisture contents, meet. Okay, it's a zone between two air masses with different moisture content. Okay, 2.2. Identify two winds at A and B that will converge at the moisture front. Okay, we mentioned that the Indian Ocean is responsible for our warmer air that comes in from the northeast. Okay, so all the air that moves in from the northeast is going to be the warm, and all the air that's coming from the southwest is going to be the cooler air coming off the Atlantic Ocean. Now, I'll carry on with these questions after a short break. Pumi?
Oh yes, guys, let us just take this quick ad break, but remember, please don't post on the wall those guesses that you have. Remember, you have to choose between 0 and 9, any number from those. Right now, let's take a break. And welcome to the last segment of our lesson in geography today. We have Michelle and our mindsetter Sviso in studio with us. But before we get to see them right now, guys, let me just quickly remind you that we are having this competition that we've been running since yesterday. This is our winter school revision for all the exams. However, guys, let's just go straight to the board and see what is the lucky guess. Let's stop the clock and refresh and see who is the lucky winner. As we refresh, guys, let me quickly remind you that we're also going to be having another live show right today. So what you have to do is just to log on to our Facebook page to get the information on how you can enter in order for you to win. And right now we have 1 as our lucky number. So I guess all the number ones out there, congratulations. Any one of you who made that guess on the show today will definitely get to win this awesome music CD given to us by Soul Candy. So basically what's going to happen is they are going to be getting that, and right at the end of today's live shows, one of you guys will walk away with this awesome case. All right, it has nice little pockets in there where you can keep all of your cities safe. Now guys, one other exciting thing that I have for you at home is that for all of you guys who enjoyed our winter school shows, here is a DVD with all the shows and everything like that, so you can basically get to shop online. We have the website on the page for you guys, so go there and order. And the nicest thing is, you are the first people that will be getting to order this will be discounted. So we will announce the date where exactly you can be given time to actually order and be discounted. Without any further ado, guys, let me just give Michelle her time to finish off with the lesson for today.
Thank you, Mpumi, and I look really forward to these last remaining minutes with you, and I hope you learn a lot. We were busy before the ad break looking at the development of line thunderstorms, and we said that we have a moisture front that develops. Now, a moisture front means that two different air masses with differing quantities of moisture meet at a particular zone called the moisture front. Okay. Now, over South Africa, this can be represented using a synoptic chart or synoptic map, and I've simplified it so that you can see how it works. If you have a look, you will see that my warm and moist air is coming from the northeast. Okay, let's just rewrite that quickly. Northeast. There we go. Okay. Now, it's important to remember or learn where that air is coming off from. It's coming from the Indian Ocean, but it's actually blowing out of a high pressure system. Okay, so we have a name for this particular pressure system. It's called the South Indian high pressure, and air will blow anti-clockwise out of that pressure system, hence causing the northeasterly flow of warm, moist air. If we have a look on the western side of the country, we've got another high pressure system that's developed there, and that is called the South Atlantic anticyclone or the South Atlantic high pressure. Now, air also flows out of the system from an anti-clockwise direction, and that results in the cool, dry air coming in from the southwest. So we've got warm and moist air coming in from the northeast. We've got cool and dry air coming in from the southwest, and they're going to collide, they're going to meet at this moisture front. Okay, you need to understand how that works, because this type of question can be asked for many more marks. Let's have a look at the questions we were dealing with. Okay, there's the cross section once more. We've already established that A was the southwesterly wind, the cooler air coming off the South Atlantic Ocean. B was the northeasterly wind, that warm, moist air coming off the South Indian Ocean, that South Indian anticyclone. 2.3 asks us now to indicate which one of the two winds mentioned above is warm, okay, and then which one is going to be dry and cold. Okay, and as we've discovered from the map, the air that's coming in from the Indian Ocean, from that South Indian high pressure system, that was our warmer air, so it must be B. Okay, and if we have a look, right, our A was our southwesterly wind, it was cold, so A should be cold and B should be warm. Okay. Also notice the mark allocation. Look at what the mark allocation is, and then look at how many things they're asking for. So, although this might look like a short answer, it's only 2 things, but each of them have 2 marks. Okay, so make sure you pay attention to those sorts of things. Right. If we have a look at 2.4, it says to explain why the 2 winds identified. Okay, so why are these winds showing different characteristics in terms of their moisture contents and temperature. Now, Sifiso kindly helped me out earlier with this question, and he said that the warm ocean on the eastern side of our country is called the Indian Ocean, so it's warm. Okay, it's going to allow lots of evaporation, lots of hot air rising, and our Atlantic Ocean is slightly cooler on the western side. So our air is going to be colder, okay, and because it's cold, it's dense, it's heavy, and it sinks. Okay, and that creates more high pressure conditions. Cold air will sink. All right. So if we have a look here, A originates. Okay, A comes from the Atlantic Ocean, and it's cold. So therefore, the air above that Atlantic Ocean will also be cold. Remember, air assumes the same characteristics of the ocean which lies underneath it. B, okay, is originating from the Indian Ocean. So that's warm. So the air above that Indian Ocean is going to be really warm. It's going to rise, it's going to evaporate lots of moisture, hence creating that warm, moist airflow. Right, if we have a look, 2.5 briefly describe, okay, how a thunderstorm will develop along the moisture front. So we've already got all our components to create a line thunderstorm. We just need to put them into a logical order. We know, let's go back to my map, we know that the Indian Ocean is warm, so all of that warm air is coming in from the Indian Ocean towards that moist front from a northeasterly direction, and our cold and dry air is coming out of that South Atlantic anticyclone in an anti-clockwise direction from the southwest and meeting along that moisture front. Okay, the only thing we haven't really described is what happens after those air masses meet. So if we have a look at our diagram, it actually tells us, right? If you have a look here, you'll see that as our warm air rises, okay, it's lighter, it's less dense, so it will rise. Our cooler air, it's heavier, so it sinks. It literally wedges in underneath that warm rising air, okay? Now, if we've got rising air, as shown by red arrows here, we're going to have uplift and warm, moist air, which cools and condenses into clouds, okay? Now, you'll see this particular type of cloud has a very specific shape and it has a very specific name, okay? What cloud do you think that is, Sifiso?
Cumulus cloud. I don't know.
No problem, okay? Cumulonimbus.
Cumulonimbus.
Good. Cumulonimbus. You just have to write it down. You don't have
Cumulonimbus,
to
yes.
say it. It's not a final
Cumulonimbus,
exam.
yes.
Okay.
Yes.
So this big, puffy white cloud, usually if it's a smaller version, it's just called cumulus. Okay. But you'll see it's extending to a huge altitude. It's very high above the surface of the Earth, and you'll notice that it's got a specific shape that it forms. Okay. Where it kind of spreads out to the top of the cloud, it forms that anvil, okay, which is very characteristic of a cumulonimbus cloud.
Yes.
Okay. All right, let's have a look at the description. All right, so it tells us that the cold, dry air, okay, from the southwest, okay, will converge with the warm northeasterly air along that moisture front. Okay, so our cold, dry air, okay, will sink, and the warm, moist air will rise along that front. Okay, very important. If our air is rising, it's going to cool and it's going to condense. Okay. It's going to change all that water vapor into tiny water droplets, and billions of those water droplets will make up our cumulonimbus cloud. You must remember the name of this cloud, however difficult it might be to pronounce. You just have to write it down. Cumulonimbus clouds, okay? And when we get big thunderheads, big cumulonimbus clouds, they're associated with very heavy rainfall, okay? If we get enough development of that cloud, it can result in hail and also lots of thunder and lots of lightning. Let's have a look at our next question. 2.6. asks you to state, okay, not to explain, just to give 2 ways in which line thunderstorms impact negatively on farming activities in the South African interior. Okay, so make sure that when you're going through your paper that you're answering the question. Don't just give general impacts. Hone them in. Okay, talk about the farming industries or the farming activities in our country. Okay, so I've mentioned heavy rainfall, and I've mentioned hail, and I've mentioned thunder and lightning come out of this thunderstorm. So if we've got very heavy rainfall, lots of hail, what sort of impact do you think that would have on our crops?
Crops could die out.
Why?
Because the crops could drown with heavy rain.
Exactly. So heavy rain can result in flooding, and so our crops will die out. Okay.
And then on the farming activities, farmers would lose their jobs, I think.
Excellent. Okay, there's nothing to sell, there's nothing to process,
Yes.
they're going to lose their jobs. And we can look at a whole range of effects associated with that. If farmers lose their jobs and there's no crops to sell, it means that the company that's farming there or the farmer loses profits. It means that we can't export crops. It means we have to import more food. So from one little effect, saying our crops die, it snowballs into a whole lot of other effects. Okay? And this particular question usually isn't only for 4 marks, it's usually an essay question. So you're going to probably have to learn at least 6 things that happen when line thunderstorms impact on our farming communities. Let's have a look at some of them. Okay? There we go. It could cause floods, which will sweep away the crops, accompanied by hail, which will damage the crops. Okay? And lightning can also start a fire. Okay? It can also damage farmlands in that manner. Let's move on to our next question. All right, question 3. Says study figure 3, which shows a seasonal wind in India. Okay, now this is actually part of the CAPS syllabus for grade 11s, and it deals with the development of monsoon wind. Okay, so whenever you see seasonal wind and you see India, you're going to assume that they're asking you something about monsoon winds. Okay, right, let's have a look at the diagram. Right, you will see that your airflow is coming off the Indian Ocean, the warm tropical Indian Ocean, and it's moving towards the interior of that subcontinent. Okay, you'll also notice, let's use a different color here, that we've got a high pressure over the ocean and that we've got a low pressure over the interior. Now, one of the first things that I always teach my learners before they even get into any of these systems is that air always flows from a high pressure to a low pressure. And we call the difference between the high pressure and the low pressure a pressure gradient. Okay, so air will flow from the high pressure to the low pressure along the pressure gradient. Okay, so if you ever get a diagram and you're a little bit stuck as to where the air is going, look where the high pressures are, look where the low pressures are, and then you can automatically deduce that the air is flowing away from your high pressure. Okay. Now there's a reason that we have low pressures in India at this time of the year. Okay, so before we even move on to the questions, little diagram here to show you the differences. If we have a look in summer in India, okay, so summer months in India occur during what months do you think, Safiso, in India?
In India, in June, from May, June, July, I think.
Excellent. So around about now, they're having their summer because it's the northern hemisphere. Okay. So in their summer, you'll notice that we have the ITCZ, which has shifted upwards. Okay. We have the ITCZ, which has shifted towards the north. Now, there's a whole other section pertaining as to why it shifts towards the north, but you just need to remember that in the northern hemisphere summer, the ITCZ will move northwards, okay? And in our summer, so in January, the ITCZ for now will move southwards, okay? So our ITCZ, all those low pressures have moved northwards, okay? Our higher pressures are over the moist, warm Indian Ocean, okay? So if we've got warm, moist air in the Indian Ocean, it will move over the subcontinents of India from the high pressure to the low pressure, okay? So what sort of conditions do you think, Safiso, will result from warm, moist air coming in over a country? What do you think it's going to be like?
It's going to be hot.
Be hot, all right?
And then it's going to create heavy rains.
Good, it's going to create heavy rain. There's lots of moisture. There's a low pressure over the Indian subcontinent, so the air will rise. That moisture will be taken up with it, and it will form lots of clouds and lots of rainfall, okay? So in this particular season, they get lots of rainfall. The opposite, which they could very well give you in an exam as well, if we have a look at our winter scenario in India that will be occurring in January, December time, you will see that our ITCZ has now shifted southwards, okay? So that means all our low pressures are now over the ocean, and all our high pressures are over the Indian subcontinent, okay? Again, our law of pressure gradient is prevalent here. Our air is going to flow out of that subcontinent towards the ocean, okay? So from the high pressure to the low pressure along that pressure gradient, okay? The air that comes from that high pressure is commonly dry, okay? So no condensation or rainfall is going to occur. So India's got two extremes when it comes to looking at their seasons. They've got a very hot summer where it rains a lot, and they've got a cooler, very dry winter period. Okay, let's go back to our question to see if we can answer it. Okay. All right, so now we know that we're dealing with a situation where our low pressures are over the interior, okay, and our high pressures are over the ocean. Okay, so that means warm, moist air is going to flow from the ocean towards that low pressure. Air is going to rise, it's going to condense, it's going to create lots of thunderstorm activity. Okay, we need to know the name. This is pure learning. We need to know the name of the seasonal wind that is created, okay, shown in the sketch. As I've said to you before, it's called the monsoon wind. Okay, you need to remember that. Then they ask you, why is it called, why a seasonal wind? Okay, now I've just illustrated to you why it's called a seasonal wind. Okay, we have a look. Our direction of that surface wind changes depending on what season that we're dealing with. Okay, so it's reversed in winter and in summer. Okay, It also operates in the hot summer, rainy conditions that are associated with the summer in the Indian subcontinent, and also with the cold, dry winter season there. It's also derived from the Arabic word, I hope I'm pronouncing it correctly, the mawsim, which means season. Okay, so any of those answers for 2 marks would have been accepted. 3.3, identify the season represented. We know that the ITCZ, those low pressures, have shifted northwards, so it must be the northern hemisphere summer. Okay, so the season that's represented was the northern hemisphere summer. 3.4, it says, although people fear the arrival of the seasonal wind shown here, so that moist, hot air coming in off the Atlantic Ocean, okay, they are more concerned with the late arrival of the seasonal wind, okay. So they're more concerned when they're not getting that warm, moist air coming in over their subcontinent, all right. So we need to examine this from 2 different aspects. When they do get that seasonal wind, what happens? When they don't get that summer seasonal moist airflow, what happens? Okay? It asks you in the question to explain the statements in full. Now, they didn't ask you to write it in a paragraph, but from the mark allocation, you should already assume to write it in an essay format. Right. So, if it arrives, we've already established that there's lots of rainfall, so heavy flooding. Okay? If there's heavy flooding, there's going to be drowning, destruction of infrastructure. If we get flooding, it's going to destroy your personal property, result in spreading of diseases. And to finish off with our late arrival, okay, it's going to be associated with drought. Okay, so anything from livestock dying to crops dying to economic decline will be accepted. That's all we have time for today. Back to you, Pumi.
All right, guys, congratulations to the winner. It is the pre-cash. They won themselves this awesome music CD coming from Soul Candy. Congratulations to them, guys. Please make sure that you join us again tomorrow, and so that you can, or rather at the end of on our next show, we are going to be having another competition where you guys can win another CD. Remember, we are also giving away this CD pack. We are giving away the city pack, so all what you have to do is just to keep liking us on Facebook. Right now though, let's just say bye-bye to Michelle.
Thank you so much for having me. I really appreciate it.
All right. Bye, guys.
At where the dotted line is pointing to. You see the high-lying area that's separating our drainage basin? What does that call? Can you remember? Yes. No? Okay. You just need to remember it's called a drainage divide or a watershed. Okay. Let's go through some of those as well. If you have a look at point B, you will see that it occurs in between 2 tributaries. So it's a high-lying area between 2 tributaries. Do you remember that?
Interfluve.
Interfluve, very good, very good. We have a look at C. They will probably just accept that it's a tributary. It's not pointing to a confluence, so it's a simple tributary. If we have a look at E, you will see it's pointing to where we have 2 streams meeting, so that would be a confluence, as you said earlier.
Okay.
And if we have a look at D, you can see it's the end of our river system as it enters the sea. And what's that called?
The river mouth.
Very good, the river mouth. Let's move on to the next question. Right, question 2. Always important to read the instruction carefully first. It says refer to question 2, or figure 2 rather, showing a river basin. If we have a look at that diagram, you will see that there's quite a few things going on here. You'll see there's a fairly complicated stream network at B. You'll see that there's a dotted line to represent a river at A. You will see the river Ron at C, and you will see that there are settlements at D, and there's also a forested area not too far away. If we have a look at each of the questions, it says to identify the type of river labeled A. So if we have a look here, a dotted line when you're looking at your map, okay, usually represents a river that doesn't flow all year round.
Can I try?
Yes, of course.
Non-perennial.
Non-perennial, very good. It means it doesn't flow throughout the year. There are other options though. Let's have a look at them. Okay, so the type of river at A could be non-perennial, or they will accept periodic, or they will accept seasonal.
Yeah.
Then it says to determine the stream order at B. Let's have a look at B. You will see at B you've got quite a few streams, and we need to determine that stream order. So the best way is to start from the outside, okay, from the earliest points of your river streams, and work your way in. So if we have a look, if we just use a couple of colors here, you will see that we've got a stream starting all the way at the top by Cap Mountain. Okay. I'm going to stop where it joins another stream. If you have a look, another little stream, and you'll see that they are joining together. Those two little pink streams that I've just drawn in are called first order streams. So your first tributaries, the first streams which flow from your watershed towards a confluence, is called a first order stream. When we have two first order streams joining, it now becomes a second order stream. It follows on that if two second order streams join, they become a third order stream. Now I've got a diagram here to show you what I mean a little more clearly. If you have a look at the color representations here, you will see that two first order streams have to join together to make a second order stream, and two second order streams have to join together to make a third order stream. All right, so Sfisu, if you have a look at that diagram, or the one that you've got on your page, can you figure out, or have you figured out what the stream order should be?
Should be stream order. The third, 3.
Very good. It's a third order stream. So it's very important that you actually take in some color pens, or take in different colors, and actually draw on your paper so that you can figure out what the different stream orders are. Move on to the next question. It says here, explain how the forested area will affect the stream discharge. And they've told you
Hello everybody and welcome to myself Learn Extra. My name is Julie, and today we are having this awesome teacher in studio with us. It is Michelle. Hello Michelle, how are you doing?
Hi, Jimmy, I'm fine, thanks. And you? Thank you so much for having me.
Great stuff. So Michelle, which school are you representing?
I'm representing 4Ways High School in 4Ways.
Oh, great stuff. Wow, it was so good to be with you today.
Thank you. No, I'm very nervous, but I'm very excited.
Great stuff. All big stuff. So this is who we just tuned in right now. Welcome to the show. And yes, we also do have another non-center in studio with us who is going to be joining us, take off some pictures that Michelle will be asking him as well. So hello, Stephen. How are you doing? Hello, Stephen. Oh, great stuff. That's just how it is, guys. Please remember to jump on the page so that you can participate on the show with us right now, right there on myself.co.za/learn/extra/winter school. It's just as simple as that. And one of the greatest things that I have for you guys is that we are having this awesome competition coming from Soul Candy. We will be giving away these awesome CDs. One of them is a lot of them, and we gave people since the mindset was just yesterday, and we gave away one in the on the last show that we had. So all what you have to do is just to open this competition on our website. It is myself.co.za/learn/start-become. So basically what happens is you choose any number between 0 and 9. Choose that number, and it is going to be taken from the numbers of lights that we have. We will be taking the last digits on the number of lights that we have. All of the information will be posted on our Facebook page. So always have to do just to go straight there and read through and see what we are about. Right now, without any further time, let me just give Michelle a chance to teach us a little bit more about geography.
Thank you so much, Camille. Alright, today we're going to go through some of the questions from the Geomorphology and the Climatology section from the February 2012 NPS paper. Have a look now. Let's move straight on to our first question. Okay. Question 1 says, refer to figure 1, which shows fluvial features, and give one term for each of the statements below. Let's have a look at the diagram. What is always extremely important to do before attempting to answer any of the questions is to make sure a person reads the instruction properly, and also to have a look at each of the definitions on the given diagram so that you can identify them for yourself before answering. If we have a look at each of these definitions, let's go through them slowly to make sure that we understand. So have a look at the first one here, a confluence. If you have a look at where confluence is pointing to, you will see that it's pointing to where two small streams or small tributaries are meeting. So in other words, a confluence marks the two streams which join at a particular point. If we have a look at the word surface flow, surface tells us that the water is flowing above the ground surface, so on the surface of the earth. If we have a look at interflow, you might have recognized similar terms such as spurs and flux in the grade 9 syllabus, but an interflow in this context means that it's a high-lying area which separates individual tributaries. If we have a look at watershed, watershed can also be used with the term drainage divide, and it means the high-lying area which separates one drainage basin from the next. If we have a look at the term river mouth, you will see that it's pointing to literally where the river ends. So where our river ends and enters into the sea, that is known as the river mouth. Now that we've had a look at our diagram, let's see if we can answer the question. You'll note that each of these short questions is worth 2 marks each, but your one term or your one word will constitute those 2 marks. 1.1, water that flows on the surface after it rains. So it flows on the surface after it rains. Surface is our key word here. So if you have a look, surface flow. And you will see that that was on the diagram. Most of the time you can actually look at your diagram and they give you key pointers there. 1.2, a high-lying area that separates 2 different drainage basins. Okay, it separates 2 different drainage basins. As I said before, watershed, or they will also accept the term drainage divide. 1.3, water that is found below the surface of the earth. Okay. As was pointed out in your diagram, groundwater. 1.4, the point where the river enters the sea, as indicated on your diagram, river mouth. And lastly, for this particular little question, it shows the division between the tributaries, individual tributaries, in the same drainage basin. As was on your diagram, the term interflow. Any questions so far? Awesome. I just want to reinforce a couple of those terms. You will notice that the same diagrams will not come up time and time again in each exam that you've written. So what will help you is to actually do a simple Google image search and to look at various features like drainage basins or mesas and buttes when you get to that, and you'll find that there are literally millions of versions of those diagrams. So the more you look at those diagrams, the easier it becomes to identify those features. Right, now, Lisa, let's see if you've learned anything now. A, if you have a look